Our project is Calgary Flight information, weather, and flight CO2 emission estimation, and our team is Alyssa and Siri and Karun. First, we'll talk about project goals and data pipeline. Project goal is develop a data pipeline integrating daily flight information from YYC Airport, Calgary hourly weather data, and flight distance and carbon emission estimates. Data ingestion involves daily flight information from YYC Airport website via web scraping, alphabetical IATA airport code list from Wikipedia, Calgary weather and flight carbon emission estimation via API. For data transformation, our strategy involves integrating flight information with the IATA World Airport List to enrich our dataset with additional details, such as date, country, airport code, and airport name, in addition to flight schedule, status number, gate, airline, and city. For data serving, we aim to generate insightful visualization from the enriched Calgary flight dataset, weather and flight delay prediction, and flight CO2 emission and distance estimation user interface to provide deeper insights into the flight data. For data storage, currently we use S3 bucket to store our lookup table, flight data, and visualization. As for deployment, we utilize Streamlit for the web application, create Docker image, and deploy on AWS Fargate for stability and scalability. Now I'm going to talk about data collection and storage. Flight info data collection. We utilize Selenium, Chrome driver, Python libraries for real-time flight data scraping from YYC Airport website. We schedule tasks with cron job on an EC2 Ubuntu instance for daily update, generating arrival and departure data frames. We opt for S3 storage over RDS due to potential cost implications as data volume grows with daily scrapes. For weather data, we implement integration with a weather API for daily hourly weather condition in Calgary. Store retrieve data as a CSV file in an S3 bucket for further analysis and utilization. As for the CO2 data, initially our plan was to integrate distance and CO2 emission data into our flight information. However, due to API limitations restricting us to only 200 calls per month, we have adjusted our approach. Instead, we will make this feature interactive by allowing users to input departure and destination cities. And in return, we will display the distance and carbon emission estimation. As this feature relies on demand API call, there is no need for data storage. Next, I'm going to talk about data transformation. After we got the flight schedule from the web scraping, we merged the flight schedule with airport lookup table that we create so we can add the IATA airport code, airport name, and country to the flight schedule table. Then we can calculate the CO2 emission and distance by inputting the departing and destination city. One limitation is that the CO2 estimation API we have can only estimate international airport in big cities. Let's try to change the destination to Toronto. And then we can see the new CO2 emission and distance estimation there. Let's move on to visualization and flight delay predictions. We choose for visualizations, box plots of time delay by airline, histogram of time delays, pie chart show international versus domestic flights, distribution of schedule, arrival, departure time. Two visualizations focus on time delay between schedule and actual arrival or departure. Other two visualizations highlight proportion of international versus domestic flights and distribution of schedule time. Note that the morning gap in the scheduled flights is interesting. I always assume that the airport operates 24/7. Provided time delay prediction based on current weather at the airport to assist traveler in organizing itineraries or pickup. Models consider current weather data from an API, including ambient temperature, dew, humidity, precipitation, snowfall, wind speed, wind gusts, and visibilities. Trend model on data collected from March 15 to April 5, 2024, comprising over 4,000 data points. Export trained model using job-lib libraries to enable reuse without retraining. In Streamlit scripts, we loaded job-lib files, make weather API call, and utilize models to predict time delay. Finally, we are now ready to show you our web application features. We can query date to retrieve arrival and departure schedule, and we can enter city pair for carbon emission and distance estimation. Let's try different pair. Let's do Toronto and Calgary. Then we can see the carbon emission and distance estimation here. Then we can also select different page to our visualization page. And here we can also query the date and get the visualization for departure and arrival. So let's try another date here, and then you can see the plot change. And we have 4 plot for departure and 4 for arrival. Also, we had viewed the today's time delay prediction based on current weather. This concludes our presentation. Thank you for watching.